We're about to pull back the curtain on something that's absolutely critical to modern medicine, but you probably never even see it. We're going to unpack the very bedrock of trust: medical validation. I mean, really think about this for a second. When you're dealing with something as complex as, say, cellular therapy, how can we be absolutely certain that it's safe and reliable? Not just once, but every single time? Well, there's an answer, and it's this incredibly meticulous process that we're going to dive into. All right, so here's how we're going to break it all down. First, why this is so important. Then, we'll clear up the difference between qualification and validation. After that, we'll look at the master plan, the team behind it, what happens when things change, and wrap it all up by talking about that bedrock of trust. Let's jump in. Okay, first things first. Why does any of this even matter? Well, the stakes could not be higher, especially when you're talking about something like cellular therapy, where the medicine is literally living cells. This quote really nails it. The whole point is to ensure satisfactory, safe, and reproducible outcomes. What does that really mean? It means you have to guarantee that if you put the same things in, you get the exact same safe result out every single time. There's just zero room for error. So you can really think of this whole system as a kind of invisible safety net. It's this whole web of checks and balances, all working in the background with one single purpose: to protect the patient. All right, let's get into the nuts and bolts. We're going to build our confidence step by step. And to do that, we have to get really clear on two key terms you hear a lot: qualification and validation. They sound similar, but they're totally different. So first up, qualification. The easiest way to think about this is checking the individual parts. It's all about making sure that tools you're using, the equipment, the supplies, all that stuff, work exactly the way they're supposed to every single time. And then you've got process validation. This is where we zoom out and look at the big picture. It's the hard, documented proof that the whole process, using all those little parts we just qualified, actually works. It proves that the entire system can reliably create a final product that is exactly what it needs to be. Let's break this down even more. Think about a car factory. Qualification is like checking each individual robot on the assembly line to make sure its bolts are tight and its programming is right. It asks, does this part work? But validation, that's like taking the finished car off the line and crash testing it to make sure the whole system built a safe car. One checks the parts, the other proves the final result is what you wanted. So how do you manage something this complex? Well, that's where the validation master plan comes in. You can think of it as the ultimate blueprint for getting the same results over and over again. And this thing is seriously detailed. The master plan, or VMP, it covers everything. It defines exactly what you're testing, the methods you'll use, all the qualification steps. It even spells out how to analyze the data and, most importantly, what good looks like, the acceptance criteria. It even plans for the future by setting rules for when you need to do it all over again. And here's the flow of how it all works in practice. You don't just jump in. First, you have to figure out what's actually critical. I mean, you can't test everything to the same degree, so you focus on what impacts patient safety the most. Then you do a risk assessment, build out your plan, qualify all your gear, and then you finally run the big validation tests. And of course, nothing is official until it's been formally reviewed and signed off on. Now let's zoom in on just one of those steps for a second: qualifying the equipment. Because yeah, even that single step is a whole process in itself. This is so cool. It's not just one check, it's actually a 4-step process. You start with design qualification, or DQ. That's just asking, did we even pick the right machine for this job? Okay, you did? Great. Next is installation qualification, or IQ. Is it plugged in and set up right? Then you have operational qualification, OQ. Does it turn on and do all the things the manual says it should do? And finally, the big one, performance qualification, PQ. This is the real-world test. Does it actually work consistently as part of our real process? See how each step builds on the one before? It's just super logical. Of course, a system this detailed doesn't run itself. It takes people, a whole team of experts actually. So let's talk about who's behind the curtain making all this happen. You know the saying, it takes a village? Well, that is absolutely true here. This is not a one-person job. You've got the program director, who's ultimately responsible, but then you have the quality manager making sure the process is sound, the facility director is involved, and you've got a whole dedicated team with people from different departments. They even bring in outside experts, like the people who actually made the equipment, to make sure everything is perfect. Okay, so let's imagine you've done all this work.
Everything is perfect. Your process is fully validated. But what happens when something changes? You get a new machine, or a supplier changes a material. How do you adapt without breaking everything?
The answer is a process called change control. And this is brilliant. The point isn't to stop change from happening. That's impossible. The point is to manage it. It's a formal system for looking at any proposed change and figuring out if it could mess with your validated state. The whole goal is to make sure the system stays safe and reliable, no matter what.
And the way it works is just common sense, really. Someone suggests a change. The very first thing that happens is a risk assessment. And it all boils down to one simple question. Could this change have a negative impact? If the answer is no, then fine, you handle it through normal procedures. But if the answer is yes, or even maybe, then bam, you have to stop and completely revalidate the process. It's a critical safety switch that prevents any small change from causing a big problem down the line.
And that brings us right back to where we started, the bedrock of trust. Let's pull all these threads together and talk about why this technical stuff matters so much to all of us. When you put it all together, the big plan, the tiny checks, the validation runs, the change control, you start to see it's so much more than just paperwork. Every single check, every signature, it's like another brick being laid in this huge foundation, a foundation of safety. So if you remember anything from this, remember these key things. First, validation is all about making sure medical procedures are safe and repeatable. Second, this isn't a one-and-done kind of thing. It's a living, breathing system with a master plan. Third, it takes a whole team of experts to pull it off. And finally, that change control system is the guardian that keeps it safe, even when things evolve. And that's really the whole story. Medical validation is this amazing, powerful, and almost totally invisible system that we all rely on. It really makes you think, right? What other invisible safety nets are out there, protecting us every single day in ways we don't even see?